maybe it's up, I can open it to the audience also, maybe can someone tell from their mind what is, IoT, industrial of things, Internet of Things, or industrial Internet of Things, I can give a pause if someone wants to give a try, and then I'll give a brief intro of what is IIoT.
All right, sir. Anyway, let me start the presentation.
Okay, sir. Sure, sir.
Right. So
wait a second, sir. Small intro about yourself and then start, sir. Please wait a second, sir. Yeah. Very fine. Good evening, Sarna Kumar, sir.
Yes, sir. Shall I start now?
Please, sir. Go ahead.
Sir, I would like to welcome our chief guest, Dr. E. Sivasankaran, sir. He is working as Associate Professor in the Department of Computer Science and Engineering, NIT, Tiruchirappalli. He has 17 years of teaching experience. He completed his BE Computer Science and Engineering from Madurai Kamaraj University, Madurai, M.Tech Computer and Information Technology from Manonmaniam Sundaranaar University, Tirunelveli, and PhD in Department of CSE from Manonmaniam Sundaranaar University, Tirunelveli. His research interest includes database management systems, artificial intelligence, machine learning, data analytics, big data analytics, and natural language processing. Under his guidance, 3 candidates completed PhD degree, 2 candidates completed MS by research, and 7 candidates doing PhD degree. He published 13 international SCI journals, 5 international Scopus journals, and 29 international conferences. He organized 1 national conference and 7 FDP's workshops sponsored by AICTE, TechCube, ISTE. He is a member in IEEE chapter. He was the co-principal investigator for the project titled Artificial Intelligence Based Integrated Logistic Management System, which was sponsored by NRB DRDO for an amount of 22.2 lakhs for the duration 2020 to 2022. He was the principal investigator for the project titled Development of Advanced User Interface with Boiler Stick Leak Signal Intensity Frequency Spectrum Capability for Belsonic, which was sponsored by Bell Tiruchirappalli for an amount of rupees 6.2 lakhs for the duration 2022 to 2023. Once again, I welcome you, sir. We are eagerly waiting for your valuable speech. Sir, please.
Yes, sir. Thank you, sir. Thank you for the nice introduction. So in today's class, I am planning to teach about working with AI and machine learning. I will teach you about the classical machine learning algorithms. So I plan to teach K nearest neighbor classifier, a basic introduction to backpropagation neural networks. And regarding clustering algorithms, I plan to teach the very classic K-means clustering algorithm, DB-scan algorithm, and give some introduction to reinforcement learning algorithm. So let me start with the basics of artificial intelligence. So artificial intelligence is making computers to do things which at the moment people do it better, right? So artificial intelligence can be defined into 4 categories. So the first thing is like thinking humanly, right? So we are going to associate human thinking with artificial intelligence. So humans are good in decision making, problem solving, and learning. So think humanly, act humanly, think rationally, and act rationally, right? So this is how we define artificial intelligence. Again, as I said, that artificial intelligence is making computers to do things which at the moment people do it better as per Rich and Knight. So think rationally means we are going to develop machines which has to exhibit intelligent behavior and do things in a correct way. Right. So artificial intelligence is a branch of computer science, which we can create intelligent agents or machines which can behave like human beings, think like human beings, and able to make decisions. So AI is used in a lot of applications, right? So AI is used in replicating human intelligence, solving knowledge intensive tasks. So nowadays AI is used in proving a theorem, a mathematical theorem, or gaming applications. It is used for simulating some surgical operations, driving a car in a traffic, so autonomous vehicle system and so on. So regarding artificial intelligence, we have 4 major categories of artificial intelligence. One is we call it as supervised learning. The other is unsupervised learning. We have semi-supervised learning and reinforcement learning. So let us study something about supervised learning. We'll discuss something about supervised learning. So in the case of supervised learning, you are going to build a model based on the training data set, right? So once a model is being built, given an unseen data, it should be able to predict the class label for the unseen data, right? So in the case of machine learning or in AI, we have 4 categories. Supervised learning, you have a training data set based on which we build a model, and once a model is being built, we are going to use it to predict the class label for some unseen data or test data. So this supervised learning can be compared to learning which takes place in the presence of a supervisor or a teacher, right? So initially a student is trained or skilled to perform an activity. So once the student is skilled in programming or in a particular activity, he will be able to do the activity by his own. It's known as supervised learning. So we have a labeled data set which is used as a training data set for a supervised learning algorithm. So based on the learning data set, we are going to build a model. So once a model is being built and successfully validated, given an unseen data, it should be able to predict the class label. We call it as supervised learning, right? So supervised learning or classification can be categorized into we use classification, as well as we call it as we can also call it as prediction. So when the output is going to be a continuous valid function, we call it as prediction. Whereas if you are going to predict categorical class labels, we call it as classification. So the typical applications of supervised learning or credit approval, target marketing, medical diagnosis, fraud detection, and so on. So let us explore the 2 major steps in classification. So in the classification, the first step is building a model, right? So model construction. So based on the tuples in the training data set, we are going to build a model. So the model can be a decision tree or a classification rule or a mathematical formula. Once the model is being built, we are going to use the model to predict the class label for the test sample for which the class label is unknown. So we have some performance metrics in supervised learning in classification, which we call it as accuracy, precision, recall, F1 score, and so on. So by this, when the accuracy is acceptable limit, we use the model to classify the tuples which are unseen. So let us see an example for a process classification model. So if you look into the data set, so in universities, in foreign universities, they have faculty members or tenure track faculty members. They will be appointed for a period of 3 years or a 5-year tenure and so on. So based on the data set available, right? So if you look into the data set, yeah, faculty members become tenure track when the years of experience is going to be greater than 6 years, or when the rank is going to be a professor, right? So if you look into the training data set, the classifier model, it creates rule like if rank is going to be professor, right? He is eligible for a tenure track employee. Similarly, if the years of experience is going to be greater than 6 years, he becomes a particular professor, he becomes eligible for a tenure track professor. So once a model is being built, right, so given an unseen data, it should be able to predict the class label. So for example, Jeff is a professor with 4 years of experience. Since he is a professor, so since he is a professor, he is eligible for a position in an university, right? So Tom is an assistant professor of experience less than 4 years, so he is not eligible for.
হ্যাঁ একটু তাহলে কথাবার্তা বলতে হবে। তাহলে তোমরা কবে যাবে? তাহলে গেলে তোমাকে নিয়ে যাব আমি।
রাইট,
শনি রবিবার, হ্যাঁ শনি রবিবার করে ডেট করে, বুঝলে? শনি রবিবার করেই করতে হবে আমাকে, দেখছি না শনি রবিবার করেই ওখানে।
Wait a second, I will mute, sir. I will mute.
তুমি আমার সাথে যাবে, এবার তোমরা যদি ওদিক দিয়ে যাও, নাহলে ইয়ে থেকে বাস যায়, বাঁকুড়া বাস স্ট্যান্ড থেকে।
right,
Go ahead. I will mute the participant.
yes. So in today's class, we'll explore two classifiers, classifier and other is going to be neural network classifier. So KNN classifier, we are going to predict the class label based on the nearest neighbors. So in this case, the training samples are described in an n-dimensional space. All the training samples are stored in an n-dimensional pattern space. So given an unknown sample based on the nearest neighbor, we are going to predict the class label. Right. So for example, I want to predict the telecom service provider of an individual. I will identify his nearest neighbors or his close contacts. So based on the nearest neighbors telecom service provider, we'll be able to predict the class label for the a particular sample. It's known as KNN classifier. So it's a simple model. So we use a distance metric. You can use a distance metric like Euclidean distance metric or Manhattan distance metric or Minkowski distance metric to predict the class label for an unseen sample. So the distance between 2 points x1 and x2 is given by square root of summation of x1i minus x2i whole square. So I plan to discuss 4 problems in today's session. So the first problem is like KNN classifier to predict the credit default of a particular individual, right? So whenever we apply for some loan, home loan or a vehicle loan, right, based on age, the loan amount, and based on the patterns available, people who have defaulted a loan or who have repaid a loan correctly, the bank will have a model. So whenever a new applicant applies for a loan, we'll compare the unseen data or a sample data with the model, and the model will predict whether a particular applicant is likely to repay the loan back or he is likely to default the loan. So we have a training data set. So this training data set contains 2 attributes and 1 class label. So age is an attribute, loan amount is an attribute, and the class label, the last column is going to be default category, which is going to be yes or no. So the first applicant age is 25 years. He has got a loan for 40,000 rupees, and he comes under the class default is equal to no. So he has repaid a loan. Whereas if you look into the last record, an applicant with age 33, he has applied for a loan amount of 1,50,000. He has availed the loan and he belongs to the category default is equal to yes. Right. So this is a training data set. This contains people who have repaid a loan as well as people who have defaulted the loan. So given an unseen sample, like a test case input for an individual applies for a loan with age 48 years and loan amount is 1,42,000. We are expected to predict the class label, like whether the person is likely to repay the loan or default the loan. So what we do is that we use a simple Euclidean distance metric to find the distance between the data points. So the test data set is going to be 48, square root of 48 minus 25 whole square minus 1,42,000 minus 40,000 whole square. So here the distance between the test data and the first data point is going to be 1,02,000. Right? Similarly, the distance between the test data set and the second record is going to be 82,000. Right? So we are going to find the distance between the data points using Euclidean distance. And once we find the distance, we are going to find the nearest neighbors. So the nearest neighbor for the test sample is going to be the nearest neighbor's distance is going to be 8,000, 42,000 and 22,000 respectively. Out of the three nearest neighbors, two neighbors, they belong to the default category is equal to yes. So we predict that this applicant is likely to belong to the test category default is equal to yes. Right. So this is a very basic, very simple algorithm. So we are going to predict the class label for an unknown sample based on the nearest neighbors. It's called as k nearest neighbor classifier. So here the k value is going to be always odd number. So based on the majority voting or based on the majority of the neighbor performance, we are going to predict the class label for an unseen sample. So this is how classification algorithm works. So based on the training data set, we are going to build a model. And once the model is being built, we are going to predict the class label for an unseen data. Right. So with this insight, let us study something about back propagation neural network. Right. So neural networks are the basic algorithms. Right. Nowadays we have convolutional neural network algorithms or LSTM or transformer based models. But neural networks are the basic algorithms that can be used for solving classification problem. So let me discuss a basic classification problem in today's class. Right. So a neural network generally consists of input layer, hidden layer, and output layer. So this layers, this input unit, output unit, and hidden layers, they are connected by some weighted connections. Right. So a neural networks, it works by adjusting the weight so that it is able to predict the correct class label for the input tuples. Right. So a neural network is similar to that of a human brain, where we have a lot of neurons that are connected together. Right. So similarly, a neural network consists of input layer, hidden layer, and output layer with some weights associated, weighted connection associated between the input and hidden layer and hidden and output layer. So during the learning phase, the neural network learns by adjusting the weights so that it will be able to predict the correct class label for the input tuples. So the neural networks involve long training times. So you need to train the neural networks with a large volume of data, and neural networks are usually criticized for their poor interpretability. So now we have this explainable artificial intelligence where we are trying to interpret why a particular neural network produces some results. However, the old neural networks, they take a lot of time for training and they are criticized for poor interpretability. However, the advantages of neural network is that they can work with noisy data and they are able to work with patterns they have not been trained. Right. So they can be used when there is some little relationship between the attributes and the classes. So let us see the algorithm for a neural network. So this is how a neural network looks like. I will show you the diagram of a neural network. So this is how a neural network looks like. You have input layer, you have hidden layer, and you have an output layer. So we have weighted connections between the input and the hidden layer. So W14 denotes the weight between the node 1 and 4. So 1 is an input layer node, whereas 4, the node 4 is going to be a hidden layer node. Right. So for each and every neuron, or for each and every neuron, we are going to compute the weighted sum of inputs plus bias. So a neural network works on the policy like we are going to compute the sum of weighted sum of inputs plus bias, and then we'll compare it with some threshold value. We'll look for some activation functions. So basically there are two types of activation functions. In basic neural network, we have a sigmoid activation function where the output is in the range 0 to 1, whereas in the case of tanh activation function, the output is in the range -1 to +1. So they are used to skew the results in the range either 0 to 1 or -1 to +1. So a neural network, a backpropagation neural networks, we work by comparing the output, actual output with the target output, and we are going to backpropagate the errors. So error is the difference between the actual output and the target output, and we are backpropagated, and we are going to adjust the weights of the neural networks such that it should be able to correctly recognize a particular input. Right. So let us see the steps in a neural network, and we'll solve a simple problem using neural networks. Right. So neural networks, the first step is that you are going to initialize the weights between the neurons. So the weights are initialized to a small random values in the range -1 to +1 or -0 to 0.1. Right. So you are going to initialize the weight values as well as the bias values. So each training sample, the input sample is processed by the following steps. So we are going to compute the weighted sum of inputs plus bias, right? So in this step, we are going to go compute the net input and output of each unit in the hidden as well as the output layers, right? So a neural network, a neuron in a neural network works by we will be computing the weighted sum of inputs to a particular neuron plus bias, right? So we'll have an activation function. We'll have an activation function applied in the output layer. So this activation function is also known as squashing function. So it is used to map the input from a larger domain to a output in the smaller range 0 to 1. Right. So this logistic function allows the backpropagation algorithm to model classification problems that are linearly separable. So linearly separable means we'll be able to have a hyperplane that best separates two different classes. So as we have seen, we are going to find the weighted sum of inputs plus bias. Then for this output, we are going to apply an squashing function. So here we are going to apply a sigmoid function, which is going to give us, which is going to map larger domain into smaller domain in the range 0 to 1. So this logistic function allows the backpropagation algorithm to model classification problems that are linearly separable. Right. So for each and every neuron, we are going to compute the error, and the error is propagated backwards by updating the weights and bias to reflect the error of the network prediction. So error, we are going to compare the target output and the actual output. So the difference between target output and actual output is going to be the error. And the errors are propagated backwards from the output neuron to the hidden neuron, from the hidden neuron to the input neuron. So the weight updation takes place as well as the bias updation takes place. So you need to adjust the weights and bias of your neural network in such a way that it should be able to predict the class label for an unseen sample, right? So this is going to be the error value associated with the output layer. So we also have an error value associated with the hidden layer, which is given by OJ 1 minus OJ, right? Summation of error k WJK, where WJK is the weight of the connection from the unit J to the unit K. Right. So once we are going to propagate the errors from the output unit to the hidden layer, again the weights are the errors are propagated. The error value is propagated from the output layer to the hidden layer, then hidden layer to the input layer. We are going to perform weight updates as well as BIOS update, right? So the weight is incremented by a lambda value. Similarly, the BIOS is also incremented by a lambda value. So this is how the learning takes place. So here the variable L is a learning rate, and its range is usually in the range 0 to 1. So this learning rate helps to avoid getting stuck at local minimum, right? So this is how a neural networks, a backpropagation neural network works. So here the terminating condition for a neural network is that when the weight increments are so small below a specified threshold level, we stop the neural network, right? The other terminating condition is that a pre-specified number of epochs training has expired, and a percentage of samples misclassified in the previous epoch is below some threshold value. So the accuracy is very high. We stop the neural network. When the weight increment is going to be very small compared to the previous epoch, we stop the training, or we stop the system or a neural network once a pre-specified number of epochs have been expired, right? So this is a algorithm, right? So algorithm in a single present slide I have given. So we are going to have a neural network. Initially, you are going to initialize all weights and BIOS in a neural network. So while the terminating condition is not satisfied, what we do is that we are going to propagate the inputs forward. We are going to compute the output from each and every input unit, as well as we are going to compute the output from the hidden layer as well as from the output layer. So output layer, we are going to use an sigmoid function or a squashing function to skew the output in the range 0 to 1, so that the patterns are linearly separable, right? Then we are going to back propagate the error from the output unit to the hidden layer. Then again, the errors are back propagated from the hidden layer to the previous layer or the input layer. So finally, once the errors are back propagated based on the error values, we are going to perform weight update as well as BIOS update. And this is how a back propagation algorithm works in a feed forward neural network. It is used for prediction. So I have taken an example for sample calculation for one epochs by like Giavi Horn and Michael Hamburg textbook. So here the input pattern is going to be 101, and the class label is going to be 1. So for this pattern, I am going to train a backpropagation neural network algorithm. So the learning rate is given as 0.9. So this is how we are going to initialize the weight and BIOS values, right? So the input is going to be x1, x2, x3 is going to be 1, 0, 1, and output is going to be 1, and you have some weights initialized in the range minus 1 to plus 1, right? So the weight between the neuron 1 and 4 is given by 0.2, and the weight connection between the neuron 1 and 5 is given by minus 0.3, and so on. So you have some weights associated between the different neurons in a neural network. We also have some values for the BIOS. The BIOS associated with the hidden layers, hidden neurons 4 and 5 is going to be minus 0.4 and plus 0.2 respectively. And finally, there is a BIOS associated with the output neuron. So we have BIOS associated with the hidden neurons as well as the output neuron, and you have weight values associated between the different neurons in input layer, hidden layer, as well as in the output layer, right? So we are going to apply the calculations, right? So we are going to find what is going to be the input to the neuron 4. So input to the neuron 4 is going to be x1 into W14, x2 into W34, W24 X3 into W34. So you all know that 1 into W14 is going to be 0.2. So input is going to be X1, X2, X3 is going to be 101. So 1 into 0.2 plus 0 into 0.4 plus 1 into 34 is going to be 0.5, right? So 0.2 plus 0 minus 0.5 minus bias. So what is the value associated? Bias value theta j value associated with this neuron 4 is going to be it is going to be minus 0.4. So we are going to find the weighted sum of inputs plus bias. So 1 into 0.2, right? So 1 into 0.2, 0 into 0.4, 1 into 0.5 minus 0.5 minus 0.4, right? So this is how you get this weight, the total input to this neuron 4, which is going to be the net input to the neuron 4 is going to be minus 0.7. Then we are going to compute the output value. So we are going to apply a squashing function or a sigmoid function, so that we are going to transform the output in the range 0 to 1. So 1 by 1 plus e power minus ij. So this minus 0.7 is given as input for this output. So 1 by 1 plus e power 0.7 is going to be 0.032, right? So this is how we compute the net input to each and every neuron, as well as the output from each and every neuron, right? So the first step is that you are going to compute the net input to each and every neuron and net output from each and every neuron. Then we are going to calculate the error at each node, right? So the error value is calculated by OJ 1 minus OJ, TJ minus OJ. So output error at the node 6 is given by what is the value? Or the output at the neuron 6 is going to be output at OJ, and 1 minus OJ is going to be again 1 minus 0.474. True output minus actual output is going to be again 1 minus 0.474, which is going to be, so you get, this is the error associated with this output neuron 6. Similarly, we are going to back propagate the errors, and we are going to find the errors associated with the nodes in the intermediate nodes. So again, it's going to be OJ 1 minus OJ. So 0.525 is going to be the output associated with the fifth neuron. 1 minus output at that particular neuron is going to be 1 minus 0.525. So the error in the previous layer is propagated backwards, and this is going to be the weight associated with so W minus 0.2 is going to be the weight associated between 5 and 6 neuron, right? So similarly, we are going to calculate the error at each node. So once error is calculated, error is back propagated, we are going to calculate the new weight values. So the new weight value is going to be old weight value plus L into error J, right? So the weight, the initial weight values between W46 was so minus 0.3 minus 0.3 plus L is the error rate, and this is going to be 0.1311 is going to be the error value at the node 6, 0.1311, and 0.332 is going to be the weight between the node 4 and 6, right? So we are going to calculate the weight updaters, the old weight plus landing rate, error at that particular node, as well as OI. So the output at that particular node is given by the sixth node. The sixth node, the output is going to be So the old weight was minus 0.3, landing rate was 0.9. The error as well as the output at that particular node. Error at node 6 is given by 0.1311, and the output at the 6th node is given by 0.474. Right. So here it's going to be 4 to 6. So OI. So OI is going to be 0.332. So based on this, you are going to update the weights and bias. So this is the calculation for a single epoch. Right. So this is how a back propagation neural network algorithm works. So I will share this materials with you. You can go through it. So the mathematical calculation looks very simple for a single epoch. Right. So you are going to compute the net input to each and every neuron. You are going to compute the output associated with each and every neuron. We are going to apply a sigmoid function or a squashing function so that the output is mapped in the range 0 to 1. We are going to calculate the error associated with each and every neuron. We are going to back propagate the errors from the output neuron to the hidden neuron, and the errors are again back propagated from the hidden neurons to the input layer. Then the final step is that we are going to perform a weight update as well as bias update. So bias again, bias update is like old value of the bias plus L into error J values allowed. So this is how L into error J values allowed, whereas weight update is going to be L into error J into OI, the output associated with that particular node OI, which is going to be 4. The weight associated with 4 is going to be right. So this is how weight update and bias update takes place. So this information, like working with basic back propagation neural network algorithm, you can get it from Yavi Hahn or Michael Hamber textbook from by Elsevier publishers, data mining concepts and techniques. Right. So this is about working with a basic back propagation neural network algorithm. The other thing that I want to discuss was that I want to discuss about unsupervised learning. Right. So unsupervised learning is also known as clustering. Right. So clustering means grouping similar objects together. Right. So like we need to cluster similar data points together in an n-dimensional space. We call it as clustering. So in the case of clustering, there is no training data set. Right. So we have only test data set available in the case of clustering. So we'll be grouping similar objects together based on the distance metric or similarity metric. The objective of any clustering algorithm is to maximize the intra-class similarity and minimize the inter-class similarity. Let me show you a simple example of clustering algorithm. Right. So I will share. I will share a simple clustering algorithm. All right. I hope the screen is visible to you. Let me.
Yes, sir, visible.
Right. So the case of clustering algorithm, we'll see a very old classic algorithm, k-means clustering algorithm. So given n data points, we are expected to create k number of clusters where k value is going to be less than n. So this k-means clustering, the property is like partitioning based approach. So here the idea is that we are going to partition the data points into k number of clusters where k value is going to be less than n. So here we have two conditions. Each and every data point should belong to only one cluster, and a cluster should have at least one data point at a particular time. Right. So here what we do is that initially we'll plot the data points in an n-dimensional data space, and we'll be randomly choosing k number of clusters, right? So among n data points, randomly we'll choose k number of clusters. We'll use some distance metric like Manhattan distance metric or Euclidean distance metric, and assign each data point to the nearest cluster, right? So once all the data points are assigned to the nearest cluster, we find the mean of all the data points in a cluster, right? So we find the mean of all the data points in a cluster, and we get new cluster centers, right? So again, we'll repeat the process. So we'll again find the distance between each and every data point and the new cluster centers. We'll assign the data point to the nearest cluster center. We continue with this process until the process converges, right? So when does the clustering process converges is that all the data points are repeatedly assigned to the same cluster, or the cluster mean does not change. We say that clustering algorithm converges. So let us see a simple example for clustering. So this is a very standard example for clustering. So assume that we have 8 data points, and we are expected to cluster this 8 data points into 3 clusters, right? So we have 8 data points: A1, A2, A3, A4, A5, A6, A7, and A8 data points. We are going to cluster into 3 clusters. So we are going to randomly choose 3 data points as the cluster centers. So we have A1, A4, and A7 as the data points as the cluster centers, and we have used a simple distance metric, Manhattan distance metric to associate each and every data point to the cluster center. So the distance between 2 points x1, y1, x2, y2 is given by the absolute value of x2 minus x1 plus absolute value of y2 minus y1. So we are going to assign each and every data points to the nearest cluster. So let us look into the first data point. The distance between the data point 2, 10 and 2, 10 is going to be 0. 2, 10 and 5, 8 is going to be 5 minus 2, which is going to be 3. 10 minus 8, which is going to be 2. So we get the distance value as 5. It's an absolute value of x2 minus x1 plus y2 minus y1. Similarly, the distance between the data points 2, 10 and 1, 2 is given by 2 minus 1, 1. 10 minus 2 is 8. So it's going to be 9. So among the 3 distance values available, the distance between 2, 10 to 2, 10 is going to be 0. So we are going to assign the data point 2, 10 to the cluster 1. Let us check for the second data point. The distance between 2, 5 to 2, 10 is going to be 2 minus 2, 0. 10 minus 5, which is going to be 5. So the distance between 2, 5 and 2, 10 is going to be 5. 2, 5 and 5, 8 is going to be 3 plus 3, 6. 2, 5 and 1, 2 is going to be 1, 3, 4, right? So here the distance is going to be, the second data point is closer to the third cluster. So we are going to assign the second data point to the cluster 3. So similarly, we repeat it for all the 8 data points. Once all the data points are assigned to a cluster, we are going to find the mean of all the data points in a cluster. So for example, cluster 1 contains only one data point, 2, 10. Whereas cluster 2 contains 5 data points, right? And cluster 3 again contains 2 data points. So we are going to find the mean of all the data points in the cluster. So 2, 10, the mean is going to be 2, 10. So how do I find the cluster mean of cluster 3? It's going to be 2 plus 1 divided by 2, 5 plus 2 divided by 2. So it will be 1.5, 3.5. Similarly, I want to find the cluster mean of the cluster 2. I have 5 data points. So it will be x1, x2, x1 plus x2 plus x3, x plus x4 plus x5 divided by 5, comma y1 plus y2 plus y3 plus y4 plus y5 divided by 5. Right? So this is how we get the values 6, 6 respectively. Right? So these are going to be the new data points, new cluster centers. Right? So once we apply the k-means clustering algorithm, the first iteration we get 2, 10, 6, 6 and 1.5, 3.5 as the new cluster centers, right? So again, we repeat the same process. So we are going to map the data points, all the 8 data points to the nearest cluster centers by using this Manhattan distance metric, right? So we are going to assign the data point to the nearest cluster center, 2, 10 to 2, 10, 0. So C1 data point 1 is assigned to the cluster center 1. 2, 5 to 2, 10, the distance is going to be 5. 2, 5 to 6, 6, the distance is going to be 4 plus 1, 5. 2, 5 to 1.5, 3.5, the distance is going to be 0.5 plus 1.5, 2. So here the second data point is assigned to the cluster C3. So we repeat this process. We assign all the data points to the new cluster centers. Once all the data points are assigned to the cluster centers, we find the mean of all data points in a particular cluster, right? So in cluster 1, we have 2 data points, A1 and A8. So how do I find the new mean? It will be 2 plus 4 divided by 2 plus 4 divided by 2, 10 plus 9 divided by 2, which will be 3, 9.5 respectively, right? The new C1 will be 3, 9.5. The new cluster center for C2 will be 8 plus 5 plus 7 plus 6 divided by 4. So 26 divided by 4, 12, 17, 21 divided by 4, which will be 6.5 and 5.2 respectively. And in C3, cluster C3, we have only 2 data points. 2 plus 1 divided by 2 will be 1.5 and 5 plus 2 divided by 2 will be 3.5 respectively. So these are the new cluster centers, right? So the third iteration, again, we are going to find the distance between the data points using a Manhattan distance metric, and we are going to assign the data points to the nearest cluster center, right? So we continue the process till iteration 4, and iteration 4 we stop it. So as I said that there is a convergence in iteration 4. So when we stop a clustering algorithm, is like the data points are repeatedly assigned to the same cluster, and when the cluster mean does not change, right? So in iteration 3 and 4, the data points are repeatedly assigned to the same cluster and the cluster mean does not change. We stop clustering. So we say that the data points A1, A4 and A8, they look similar and they form cluster C1. Similarly, the data points A3, A5 and A6, they look similar and they form a cluster C2, and A2, A7, they form a cluster or a group. So this is how k-means clustering algorithm works. So it's a very simple algorithm, right? So we have n data points. We are going to cluster it into k number of clusters where k value is going to be less than n. So randomly, initially we are going to randomly choose k out of the n data points as the cluster centers. We are going to assign the data points to the nearest cluster center using some distance metric. Once all the data points are assigned to the cluster centers, what we do is that we are going to compute the mean of all the data points in a cluster. So once the mean of all data points in a cluster is computed, they become the new cluster centers. So we repeat the process. So again, all the data points are assigned to the nearest cluster centers. So once all the data points are assigned to the nearest cluster centers, we compute the mean of all the data points in a cluster. So we continue this process till the system converges. So the system converges when the cluster mean does not change, or when the data items are repeatedly assigned to the same cluster, right? So this is how clustering algorithm works. And the last topic I wanted to discuss with you was working with DBSCAN algorithm, right? So DBSCAN algorithm is like a density-based clustering algorithm. So in DBSCAN algorithm, clustering algorithm, there are two metrics, right? So here we will look for the epsilon value, the radius. So radius value as well as some minimum number of points to form a cluster. Yes, sir.
Sir, please. Sir, screen is not visible.
Yes, sir. Yes, sir. I'm sharing it, sir.
Okay, sir. Thank you.
Right. So in the case of DBSCAN algorithm, it is a popular algorithm. It's an acronym for a density-based spatial clustering of applications with noise. Here again, we are going to plot the data points in an n-dimensional space. So, right. Right. So here, in this algorithm, you need to know about. Yeah, right. So this is a very simple example for a DBSCAN clustering. So we have two criteria defined in DBSCAN algorithm. One is going to be the epsilon, the radius of the cluster. So here we assume that the radius epsilon value is going to be 4, and minimum number of points is going to be 2. So a cluster should contain at least minimum 2 data points. So let us assume that we have 8 data points, A to H, right? So we have 8 data points, 2, 10, 2, 5 till 4, 9. So we are going to find a distance metrics. We are going to find the distance between these data points using a distance metric. So here we are going to use Euclidean distance metric. So the distance between the data points A, comma B is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So it's going to be 2 minus 2 whole square, 0 square plus 5 minus whole square, which is going to be 25. Square root value is going to be 5. So we are going to create a distance matrix. So the diagonal elements will be 0 in this case, in the case of this square matrix, and the elements below the diagonal will be same as the elements above the diagonal, right? So now we'll be applying the DBSCAN clustering algorithm property. Right. So here the DBSCAN assumption, the scan algorithm, we do have 2 parameters. Epsilon is going to be the radius of the cluster. So here the distance is going to be 4, and the min points is going to be the number of minimum points required to form a cluster. So from 8 within a radius 4, we have A, D, and H. Right. So these 3 data points come under the radius 4. So ADH, they form a cluster. From B, we have only 2 data points. B to B is 0. B to G is going to be 3.16. Right. Similarly, from the data point C to C is 0, C to E is 1.41, C to F is going to be 2. So C, E, F, they form a cluster, right? So the minimum number of data points should be 2. So we say that A, D, H, C, E, F, and B, G, they form a cluster. The same example, now we are going to change the hyperparameters. We are going to assume that the radius is going to be 3. So initially the radius was 4. Now we have reduced the radius to 3, and the minimum number of points is going to be 3. So here we have A to A, and A to H is going to be 2.4. So A to H does not form a cluster, whereas the distance between the data points C to C is 0, C to E is 1.41, C to F is going to be 2. So the data points C, F, they form a cluster. ADH, they form a cluster, and we say that BG data points are outliers. So no other data point is closer to B and G. So B and G, we call it as outliers, and A and D, they form border points, right? So a core point is a point with which with the minimum number of points, and within the epsilon radius, we can form a cluster. Right, so this is how density-based clustering algorithm works, right? So that's it from my side. So I wanted to discuss about backpropagation neural networks. So I have shared an example, worked the example of a simple backpropagation neural network with you. So we have also discussed about this K nearest neighbor clustering problem, which is a classic problem in classification. So based on the nearest neighbor's class label, you are going to predict the class label for an unseen sample. And in clustering, we have discussed about K-means clustering and density-based clustering. So clustering is like grouping objects together, similar data points together. So the objective of any clustering algorithm is to maximize the intra-class similarity and minimize the inter-class similarity. So we have seen two different algorithms: K-means clustering algorithm, which is an partitioning-based approach for clustering, and DB-scan algorithm, which is a density-based algorithm. So here we have given two constraints. Epsilon is going to be the radius of the cluster, and min points is going to be the minimum number of points required to form a cluster. And I have solved a simple problems using some simpler distance metric to find the distance between the points and cluster this data points. So I have shared all the materials with the organizers, so you can go through it. So I want you to be familiar with problem solving in this classic algorithms in classification and clustering. So thank you for your participation. Any questions from the audience?
Participants, please either unmute and speak. Otherwise, please use chat box too.
So there is a question
Sir,
like
one question.
yes, sir.
Parvati, okay, sure.
So which machine learning algorithm is best for a particular application, right? That's it. Like we have some major categories of clustering algorithms or classification algorithm. So like different algorithms are suitable for different applications. So there are lightweight algorithms for complex data, time series data, or multimodal data. So like no algorithm is inferior or no algorithm is very superior. So nowadays we go for some ensemble techniques like bagging and boosting models. We go for random forest or AdaBoost algorithms. In the case of classification, we go for some ensemble models which has higher accuracy compared to the conventional base learners. As I said, no algorithm is inferior or it's very superior. Like different algorithms are used for different set of applications. So if it gives you good accuracy, you can use that algorithm for your data set. So thank you all for your active participation and your support for this workshop. So the materials are shared with the organizers. So you will get it from the coordinators, the presentations and solve the problem. So kindly make use of it and try to explore more algorithms. Thank you all. Thank you for your
Thank you,
active
Sivasankar, sir.
participation. Thank you, sir.
Sivasankar,
Thank you.
thanks. Such a nice session. We are learning a lot. Very much thanks to Sivasankar, sir.
Thank you,
Ishwari,
sir.
ma'am, please, Thanksgiving, please. Ishwari, madam.
Yes, sir.
Please go ahead.
Good evening. Good evening, everyone. On behalf of Dr. Shivandi Adityanar College of Engineering, I am privileged to extend a sincere vote of thanks to all those who contributed to making the first day of our faculty development program a great success. I would like to express our deep gratitude to our esteemed speaker, Dr. E. Shivashankar, Associate Professor, NIT Tiruchirappalli, for taking the time to share his valuable expertise with us this evening. A heartfelt thanks to all our participants for being with us today from 6:30 p.m. to 9 p.m. We look forward to your continued participation in the upcoming sessions. Thank you once again.
Thank you, madam. Thank you all.
Thanks, Sivasankar, sir. Thanks a lot. Thank you, sir. Sarana Kumar, sir, please share a feedback link.
Participants' feedback link is posted in the chat box. I also posted in the WhatsApp group also.
So very sincere thanks to all the participants. So day 2 session, which will be starts tomorrow sharply at 6 p.m. Tomorrow session, which will be starts sharply at 6 p.m. We will share the link via mail as well as WhatsApp group too. We will share the Teams link, not this link. There is a separate, each day there is a separate link. So the link which will be shared via WhatsApp group as well as mail. Okay.
Okay, sir. Thank you.
Thank you. Thanks a lot. Thank you all.
Thank you. Thank you so much.